Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this short video we'll be just explaining to you about data variables and just getting us started on that section. Um, One of the things that we often need to do in a computer program is to have somewhere to store some information. It's generally not a good idea to just use what we call magic numbers. In other words, numbers that are just sitting there and don't have any name associated with them. It's much better to have a name associated with some data, and we can put a value into that. So for example, you could be dealing with the height of a building or the length of a side of a triangle or something like that. And it's important to actually give that a name as opposed to just a number, because otherwise any other programmer, or indeed yourself when you come back to look at the program later, it won't make much sense as to what exactly you were doing. So if you were calculating the area of a rectangle, for example, you'd have two variables, the width and the length, and you would give them those names. And you could then, of course, calculate the area of any triangle using that information, using those two variables, because you could then put different values into them. So they're known as variables because they can vary in value. And some of the things about variables is we have to give them a name, but we also have to say what type they are. And there are a few different types that you will use fairly often, and then there are other kind of aggregate types that you can make up after that. But the ones important to us for the moment are the int, which stands for an integer. There's the float, which stands for a floating point number. And a floating point number is a number that can have a decimal place in it. So integers are only whole numbers, 0, 1, 2, 3, 4, and of course you can have the minus numbers as well, minus 1, minus 2, minus 3. Whereas a floating point could be 3.2 or 4.7 or 0.000352, something like that. So the floating point numbers, the floating point means that the decimal point can float around, or you can move it, and therefore we can hold those decimal type numbers in there. The other one is that's worth knowing is a character, and it's given that name to suggest that it's important for holding letters, so letters of the alphabet and so on. Now the thing is, it doesn't specifically hold a letter, and we'll be doing whole sections on character variables and so on later. But the thing to remember is that everything inside a computer has to be written in binary inside the computer, so everything is a number. So in effect, what the character variable is normally used for is to hold a particular code that represents a particular letter, so that we can convert back and forth from that. But the fact of the matter is that because it is technically a number, we can multiply it by something else as well, or add it or subtract it and so on, which may or may not be useful. So sometimes the character variable is used as just a very, very small number. It's like an integer, but that doesn't have much of a range. It can only hold small numbers up to just around about 250, and I'll come back to the limits of numbers in another lesson. I don't want to get too much into it here. There are other ones as well. There's one called double. And effectively, this is just a variant of the previous one. In other words, it's a floating point number, but that can hold more precision. So you can get down to smaller numbers and larger, and you can get up to larger numbers, but it takes up more space. Okay. Now, again, as I say, I will come back in another video and talk to you about the limits of these variables. For the moment, I just want to get you to know what they are. So you must remember that every variable must have a type. Firstly, and you must specify that type. Then you must give it a name. Now, for the moment, I'm just going to give it a name like X. The important thing is that if I create another integer with a capital X, as I mentioned to you in previous videos, the capital X and the small x are considered by the compiler to be different things. So that's perfectly fine from the compiler's point of view, but from a human's point of view, if I see the capital X later on or the small x, do I know them apart? Do I know what they mean? So the thing is that I don't. So what you have to remember is you must try, when you're writing your programs, not to just use whatever you think the compiler can get away with, or that. You need to understand what another programmer, or yourself indeed, when you come back to look at your program, is going to understand. So try and keep it much more simpler than that. So even though the thing is case sensitive and you'll have to adhere to those rules, don't try and use that to your advantage by doubling up on variable names, calling some of them capitals and some of them smaller, just to get away with it. Okay. The other thing as well is that in general, it's a very good idea to give your variables a name that actually makes sense, that actually describes the thing that you're doing. So if it's the width of a triangle, then you would call it, or the width, sorry, of a rectangle, you would call it width, or you could call it rect width in order to say that it was the width of a rectangle. Okay, so try and give it names like that. So something like that, okay, would make much more sense, and next time you see that in the program, you know what it is. If you just call it X or Y, that really could mean anything, okay, so try and always give it names like that. So there are a few rules to do with naming variables, and you'll get to know them as you go on. You can use letters and numbers, so I could call this rect width 4 or something like that, but it must start with a letter. You can't start it with a number. You can put a number straight away as the second letter, that's fine, but you can't start it with a number. You can't have spaces. So you can't say int rect width. They're considered two different names, and that's going to cause confusion. It'll cause an error. So you can't have spaces. What you can do is you can use an underscore. But that's the only one of the non-alphanumeric characters that you can use. You can't use hyphens or things like that, and that you can use an underscore if you want to. Indeed, you can even get away with starting with an underscore, but that's generally not a good idea, because internal, in these libraries here, they tend to use those underscores as variable names, so it'll get confused with those in many cases. So it's generally a good idea not to use that in your own programs. Okay, so rules are you can use letters, numbers, and the underscore in the names of variables, but you can't start with a number, and you can't put spaces in there either. Okay. Beyond that, just stick to the rules of naming it something that makes sense, and try to keep them reasonably short, because otherwise you end up with the program getting out of hand. The other thing is you can't have two things with the same name, and that also means that any of the keywords like main or int or void, and there are only 32 of these in the whole C language, you can't have them as the same name. Okay, you shouldn't have it as the same name as, like, you shouldn't call a variable printf either or something like that, because that's going to get confused with the function and it'll cause the thing to fail. So they need to be unique names that you use. The other thing as well is just going back to the case sensitivity. Don't go and call this, don't go and call an integer capital MAIN, because that's going to get, even though it's going to see that as different from the main function because it uses a capital M, it's going to confuse a human if they see it. So try and stay away from that. Okay. So they're your variable names, and what you can then do is you can assign them values. I'll just get rid of these other two here for the moment. I'll stick with integers for the minute, and what I'll do is I'll give this a value. And you saw this in previous programs where I did it with an X and a Y. I'm giving this a value of 6. And I can make another one then, and I can call it rect, and I'll call that 10. Okay, or give it a value of 10. Now, you have a tendency to call this the equal sign because you've used it that way in maths, but it's important in this case, when you've only a single equals like that, you should use the word assigned and not equals, because it doesn't actually mean equals in this particular programming language. So one of the things I can do later on is I can change the value of one of these variables, because they're variables. I can change them to something else. So you can initialize them that way, or you could do this. I could say later on, I could say rect is assigned 10. I can do that there, and you should say it rect is assigned 10, because what you're doing is you're putting the value 10 in there. It's not that it's already equal to 10. Okay, so it's not a mathematical statement in that sense. What I'm going to show you here, and actually what I can do here is just I can make a second variable. You can put two variables of the same type like this. I'll call this rect. You'll notice, by the way, that when I start, when I've split up and I start a new word, I tend to use a capital letter like that. That's a convention that comes from the Java programming language. It's not specific to C or anything like that, and I could call it just rect area like that. I don't mind which you do, and generally speaking, if you go working for a particular software company, they will have a particular set of rules, style rules, that they'd like you to keep to. But what I would say to you is try to keep consistent in your own program as to how you go and do these things. Now, so we could set two variables like that. Now I could then say rect area is assigned rect length multiplied by, and we use the star for multiply, rect width. I must put a semicolon at the end of all these statements. You'll have noticed that I haven't specifically mentioned it in any of the previous videos, but you'll see that I do it at the end of each thing, and it'll be a common error that people will have at the end. It's kind of like a full stop, and you must put them at the end of each of the statements that we make. I'm going to use the printf that we learned previously, and I'm going to say area of rectangle is %d for an integer. I put a slash n so that I just go on to a new line, and then I'm going to put rect area. Okay, I'm not bothering putting in what the length and the width are for this. Okay, now so if we run that, pilot and run it, we see that the area of the rectangle is 60, which makes sense. It's 6 by 10. Okay, and I haven't said whether these are meters or otherwise. So what I could do is I could actually say meter squared. Unfortunately, because of the kind of DOS screen that this comes up with, it's not particularly good at. We couldn't put a little 2 up as a superscript or anything like that. But so I could say meter squared. So I can write that at the end of it. Now, if you recall, I said that these things are called variables because we can vary their value as we go through the program. And remember that I said that programs start at the beginning of main and they end at the end of main down here. So we go down through the thing in sequence. We've set this value to 10 and then we've multiplied the answer. What I can do is I can change the rect width to a 3. Okay, so I assign it the value 3, and I can then do a printf, and I'm going to deliberately do something which is not a compiler error, but is not doing the program the way we plan to do it. Okay, so I can say Control V, and sorry, there we go. And we will see that while I've changed the value of rect width, this will not change the area of my rectangle for the moment. And the reason you'll see, so we can see that it's still 60 meters squared in the second one that I've printed. And the reason for that is that my rect area, which is the variable that I'm using, is still using the previous value. Okay, so it's using the value before I changed it to that. So what I would have to do is I would have to carry out this calculation again. After that value has been changed to 3, that would then update this one. So it all runs in sequence, and if you haven't made that change, it's not going to occur. So we can now see that in the second case, it comes up as area of rectangle is 30 meters squared. Okay, so these are variables, and you can change the value as you go along. And indeed, some of the exercises I'll be giving you some simple exercises to learn the deal with simpler integer operations. And there are simple mathematical operators such as the plus and the minus and the multiply and the divide, and I'll be getting you to do some exercises on those. And the important thing is that you don't have to make new variables. You can just reuse the previous variables and then do another printf to see how each one of them works. And they're quite simplistic, but you'll learn a little bit as you go. Okay, so the main things that I want you to remember from this is that when you have data variables, you must give them a type. So it's very important up the top here you give them a type. But later on when you refer to them, you don't have to say that int, okay? And in fact, it would be an incorrect to do so. So it's only at the beginning that you give them a type, you give them a name. There are certain rules on the names and you'll get used to that, but you can use any number or letter as long as you start with a letter. You can use an underscore, but any other types of special characters or non-alphanumeric characters cannot be used. So you can't use spaces and you can't use asterisks and things like that. And they're the values for the names. The second thing is when you're given it a value, you use the assignment operator. That's not an equal, so don't call it an equal. Don't call it an equals. Call it an assignment in order to put a value into them. Okay. Make sure when you're giving them names, by the way, that you give them a name that makes sense. And indeed, in assessments that I give, I normally take marks off for people who call variables names that don't make sense, such as x and y. Okay, unless it's something completely abstract, which we do from time to time. And to remember that because these are variables, you can update their value as you go through the program. But remember that it won't change the value until after you've updated it. So you need to make sure that things go in the correct order in your program. Again, you'll get used to that, but it's a common mistake people make where they go and they change a value in some place, but they expect the change to have occurred before it. So for example, they change the value to 3 here, but the printf that happens before it, they wonder why it hasn't taken effect. So remember that you have to kind of think of it as it runs top to bottom in the program, and things don't happen until after. Something will not happen unless it comes below where you've made the change. Okay, so that's all for the moment.